放你这儿下啊，弄完了多少包？我手机不好。
If you can just be a bit more patient. We'll start soon, okay? Before I introduce today's guest speaker, remember no phones, please. Okay, no phones, no recording, you don't have permission, and if you're in my class, you should be taking notes anyway. Okay? I'd like to introduce our guest speaker today, which is Rob Maunder.
Hello everyone, so I guess you're on your pre-sessional course. I think you're all going to start MSc in ETS, is that right?
Yeah.
So how many of you are doing an MSc closer to computer science? How many closer to electronics? So computer science, put up your hands. About half. Electronics? The other half, okay. And how many of you are doing MSc wireless communication? MSc wireless? Nobody? Okay. Oh, you are, okay. So one or two people. So the lecture I'm going to give you now is one of the ones that I give at the start of the MSc in Wireless Communications. So if you're doing MSc Wireless, you'll get this twice, but the majority of you are not, so this is not going to be redundant for you. So what I'll be introducing for you today is MATLAB. MATLAB is some computer software which I think will be really useful to all of you, no matter whether you're doing computer science, electronic engineering, any kind of technical subject will benefit from knowing MATLAB. Okay, so I've got MATLAB running on my computer, so what I will do is keep switching between my slides and my instance of MATLAB here, so that I can show you what I'm telling you. Okay. So let's dive in. So what is MATLAB? Okay. Has anyone used MATLAB before? Yeah. Okay. So hopefully this won't be too shocking or surprising for you then. MATLAB is a piece of software. It's a tool which we can use for programming, which we can use for mathematics, and which we can use for graphics. Okay. It's basically a tool for mathematics. It allows us to investigate different bits of mathematics, to understand them, and to graphically present them as well. So it's software written by MathWorks, and it's software that you can buy. It's installed on all the university computers. There is a student version which you can pay for, but actually, if you log into software.soton.ac.uk, you can download it to run on your computer. So you don't need to pay. It used to be that you had to, but more recently, the university has a license for all the students to download and use it. So MATLAB looks like this. Actually, this is a very old version, that's 2007. I'm running here 2014, but the university computers have the 2016 version. There's the two versions every year. And they get minor updates each time. But here's what MATLAB looks like, and you can see that it can be used to produce graphics like this, and in this case what we're doing is plotting a mathematical function. Okay. So we'll get on to how that works later on. What I wanted to just do is draw your attention to an alternative to MATLAB, which is a free alternative. And I include this really because previously the university didn't have a license for the student version, and you would have had to pay, so I'll tell you about the free version. But nowadays you can get MATLAB anyway. But in any case, there is an alternative called Octave, which uses all the same interface as MATLAB. So if you write code to work in MATLAB, it will also work in Octave. It works on Linux, Windows and Mac, as does MATLAB. So I'm running MATLAB on my Mac right here, but you can also run it on Windows, on Linux. Octave is not quite as pretty as MATLAB, but you can do the same sort of thing. But we'll focus on MATLAB for now. So let's look at an example of what we might try to do in MATLAB. Okay. So here we have some mathematics. We're saying that this thing Z is equal to the difference between the sum and the product of these two things, X and Y. Okay, and that may be some mathematics that we're interested in for some reason. And perhaps we know that X has to be within the range 0 to 1, and Y has to be within the range 0 to 1. And what we're interested to know is, well, for these different values of X and Y, what happens to Z? And MATLAB is a really great tool that allows us to visualize exactly this. And here we can see the result of Z as a function of X along this axis, Y along that axis, and Z is along this one. And we'll come on to this later on. But what I want to illustrate for you is that the mathematics that we work with and the MATLAB code that implement that mathematics have some similarities. So here is the MATLAB code that generates this plot here. In fact, I've got it right here. You can see it's the same code. If I hit run on here, then it will generate that same plot that I've just shown you. And actually in MATLAB you can do fancy things like you can rotate these 3D plots. So here we can see we have an equation. Z is the difference between the sum and the product of X and Y. Well, you can see that equation written right here. Not exactly the same, but we're saying Z is equal to the difference between the sum and we've got a funny dot star, but that means the product of X and Y. You can see that the MATLAB code resembles the mathematics. Also here we're saying X is between 0 and 1, y is between 0 and 1, and that's what we're doing right here. We're saying that x is going from 0 up to 1. So don't worry about all this scaling and stuff. What we'll do is we'll talk through the use of MATLAB, and we'll build up to this later on. So let's start at the very beginning, at the basics. The simplest thing you can do in MATLAB is you can assign a value to a variable. Okay? So an example of this would be a equals 1. So here the equal sign is doing an assignment of the value 1 to the variable a. So if I hit enter, MATLAB tells me, okay, a is equal to 1. And if I ask MATLAB, what is the value of a, it will tell me a is equal to 1. Okay? So that's the simplest thing you can do in MATLAB. But already it's confusing because an assignment in MATLAB is not the same as an equals in mathematics. Okay? And this is true also if, how many of you have programmed in C or Python or some other programming language? Many of you? C, yeah? So this is common in all programming languages, is that when we assign values, the assignment isn't the same thing as an equals in mathematics. So if we look at this equation here, in mathematics, this is something that doesn't have a solution. The only a that can make this true is if a is equal to infinity. Does that make sense? Because infinity is equal to infinity plus 1. Yeah? But a equals 5, for example, it doesn't make sense. It's 5 plus 1 doesn't equal 5. So this equal sign in MATLAB is not the same as in mathematics. Okay. By contrast, in MATLAB, if we type this, and I could do that right now, what do you think I'll get? 2. Yeah, so it's doing something different. It's saying take the value of a, add 1 to it, and store that value back into a. And I can do it again. I'll get 3. Okay. So the last point I want to make on this slide is that we can use a semicolon to hide the output. So here, every time I do this, it's telling me the result. But sometimes I can just trust MATLAB to do the right thing. I don't need to check that it's giving me the right result. So I can put a semicolon at the end, and then MATLAB does the operation, just doesn't tell me the answer. If I ask now what is the answer, I get the 5, as you might expect. Okay. So sometimes we want to use a semicolon because otherwise our screen gets filled up with lots and lots of stuff. So we want to hide the less important stuff so that we can just concentrate on the more important stuff. Of course, when we're just adding 1, we haven't got much complexity, but later on things get more and more complicated. Okay, so that's assignments. So let's talk more about the variables. So in our example just now, A was the variable. Variables can have other names. We could call a variable B equals 5, C equals 2, and we've got different variables stored in our MATLAB now. And actually you can see the variables listed here. So there's the A that has the value 5 from before. I just created B having the value 5, and C I just created having the value 2. So those things are still there. A is still 5. Okay. But I can create other variables. They don't have to be just a letter. I can say Rob equals 34. I can do that kind of thing. So variable names must start with a letter, but the rest of the variable names can be any combination of letters, numbers, or underscores. So I could do hello 75 equals 3. So I can call the variable whatever I like. Okay? So long as the first letter is a letter. Also, variable names are case sensitive. So before I said Rob equals 34. If I do capital R on Rob is 23. Now you can see I've got 2 different variables here. So the capital letter makes a difference. Okay. And we can assign very big values to variables using scientific notation. So this number here is 150,000 because it's 1.5 times 10 to the power of 5. Okay. So I can do A equals 1.5 e to the 5, and there we go. A is 150,000. So that saves us hitting 0 all those times. Okay. That's variables. A bit more on variables. Variables can have different types of values. So Just now I've been assigning integer values to these variables, but we can do floating point values. So they don't have to be integers, they can be fractions, just like this. We can do complex numbers, like that. So there's a complex number. We can assign the value infinity. So now I've got Rob equal to infinity. We can test what we said before. Is infinity plus 1 equal to infinity? Yes, it is. Okay. There's some variables that are built in. So, for example, pi. You can ask what's the value of pi. We get 3.1416. E is in there. I is the square root of -1. We just saw infinity. There's a special one here, answer. So if I do an expression, 6 plus 7, but you'll notice that this time I haven't said A equals 6 plus 7. I haven't said any variable is being assigned with this value. So here is just an expression with no assignment. What MATLAB will do is it will say, well, I'll assign it for you anyway, and it always assigns it to this thing answer. So if you don't give an explicit assignment, it will use this one by default. And that's quite useful because you can quickly do an equation, and if you realise that, well, actually I needed that, then you can just grab the answer. So you could do answer plus 1, and we've got 14, and it's stored it back into the answer. Sometimes you have to be careful because it's possible for us to redefine these built-in variables. So I can do pi equals 3, and you can see now pi is over here. And if I ask what's the value of pi, I get 3, I don't get 3.14 anymore. So you have to be very careful. And a very common mistake that people make is with I. Because if you programmed in C, quite often, if you're using a for loop, you'll say for I equals 1 to 10 or something like this. And at that point, you're redefining the value of I. And if later on in your program you want to do some complex numbers, well, you're out of luck because you've changed I from being the square root of -1 to being some index of the for loop. So you have to be very careful when we redefine these things. Okay. Let's move on. So I've shown you some different variables. I've shown you real values, complex values, integers. All of these are scalars. They just have one value. But in MATLAB, we can easily work with vectors and matrices. So here, for example, just like before, we've got a scalar. Here's a scalar. But we can do a vector like this. So this is a row vector with the numbers 1, 2, 3 all in a row. And in MATLAB, we use the square brackets and these commas to separate the elements of the vector. And here we have it. A2 is now this vector 1, 2, 3. And we can do a column vector. The way we do that is we use semicolons instead of commas. If I copy this, paste it over here, now I've got a column vector. Matrices we can do as well. What we do is we type out the elements row by row, separating them by commas, and then we use a semicolon to move on to the next row. So if I copy this into MATLAB, we get a matrix, just like we have up here. And actually that's what MATLAB gets its name. The name of MATLAB is Matrix Laboratory. It's because everything is a matrix in MATLAB. And MATLAB's really useful at this because if, for example, we wanted to do this in C, we'd have to define a two-dimensional array. There would be a lot of extra coding to do just to get our matrix to appear. But in MATLAB, you can do it straight out of the box. Sometimes we want very big matrices or vectors, and we don't have to type out all the elements of the vector one by one. So there are some shortcuts that we can use. So here, for example, suppose we want to have a vector which is a row vector counting from 1, 2, 3, 4, up to 5. A very easy way to do that is to use this colon operator here. So what we're saying here is, let me copy this if I can. We're saying B1 is a vector that counts from 1 up to 5. And that's what the colon means. Sometimes we don't want to count up in 1s, we want to count up in 2s. So here we've got all the odd numbers from 1 to 9. Going 1, plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9. So here we can just put the number 2 in the middle of our colons here. And by doing this, we get a matrix, a vector that counts up in 2s. Or if you want a vector that counts down, we can put -1. in the middle here. So let's give that a try. Copy that, paste it here. It counts down. So the number that we put in the middle is how much to count by, and if it's negative, then we're counting down from 6 to 1. Other tricks we can do is we can combine vectors together. So here what we're saying is create a vector where it has two parts, the first part and the second part concatenated together. So the first part is the numbers 1 up to 3, which is what we have over here, and then the second part is the number 5, which is what we have here. So by combining different bits of notation together, we can create quite complicated arrangements of vectors in MATLAB. So it's very versatile. And there's some other quick ways to generate matrices. So here we can create an identity matrix having dimensions 3 by 3. Type that in, and it gives me a matrix where most of the values are 0, but we have 1 down the diagonal. That's what we call an identity matrix. And the number 3 here is saying it should have 3 by 3. I can make it 4 by 4. Very easy. Okay. And again, we can build up matrices by combining things together. So here we're saying create a matrix having two parts concatenated left and right. That's what this comma here is saying. First part is an identity matrix having 3 rows and 2 columns, which is what we can see here. And then the second part is a matrix full of zeros, again having 3 rows and 2 columns. That's what we can see over here. So when I copy this into MATLAB, what it will give us is a matrix that looks just like the one that I've said here. Okay, so these are quick ways to generate matrices and vectors. And we can also get into vectors and matrices to get numbers out of them. So let's suppose we've got a vector here. So let me type it in. B7 equals 4, 8, 3, 7, 1, 2, 9, 8, 5. So actually here I was a bit lazy. I skipped all the commas. And actually MATLAB doesn't really mind. If you use space to separate the elements or comma to separate the elements, it knows that you're trying to create a row vector. So I've created this variable b7 and I've filled it with a vector just the same as what we have up here. And then what we can do is we can use various different MATLAB expressions to find out stuff about this vector. The first thing we might want to know is how many elements are there in this vector. So you and I can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 elements in this vector, but MATLAB has a very particular way of telling us that. We ask it what the length of the vector is. So we say, what's the length of B7? It tells us that it's 9, because there are 9 elements in this vector. Other things we might want to do is to grab the second element out of this vector for some reason. So we can do that by saying B7, 2. So 2 is the index into the vector, and it gives us an 8 because the second element is an 8. For those of you who programmed in C, you might notice a difference here. So in C, if you want to index an array, if you want the first element, what is the index that you use? 0, right? In MATLAB, the first element has the index 1. And that's really confusing, and that is the biggest reason why it's difficult to take C code and convert it to MATLAB code, or take MATLAB code and convert it to C code. It's because they do the indexing differently. That's something to be aware of. Okay. Likewise, we can get the sixth element, which is 1, 2, 3, 4, 5, 6. If there's 2 here, we can get it by just putting the number 6 in these round brackets. And there we have it. We can do more complicated things. So here what we can do is use a vector as an input to this expression here in order to grab 3 different elements out of the vector B7. In this case, we're asking for the 7th one, which is this number 9. Okay. Then the 3rd one, which is this number 3. And then the 1st one, which is number 4. So we were expecting to get this as our output. So if I type that in, there we have it. Okay. And we can do other things. Here we're saying, from the vector B7, give me all the elements from 5 up to 7. So the 5th one is this number 1, the 6th and the 7th are there, so we get 1, 2, 9. Copy that, paste it here, 1, 2, 9. So I'm just copying and pasting just so you know that I'm not telling you lies. So you can check that it really is true what I'm saying. Other things we can do is, suppose we want to have all of this stuff here, but we don't know the length of the vector, or we're too lazy to ask. Okay, because what we could do is say, give me the elements of B7 from 5 until the length of B7. So what I could type is length of B7. And then we know that this will be the number 9, so what we're saying here is give me the elements of B7 from 5 up to 9. And when I hit enter, I get this. But I've had to do a bit of extra typing. If I'm lazy, I can just say the end. And there we go. It does the same thing. We don't need to have start, because we know that the start is always going to be 1. Okay, so there's no start concept in MATLAB, but there is this end concept. And really it just saves a few seconds of typing out the length of the vector. Likewise, you can do similar things for matrices. So let's suppose we've got this matrix A4. I think we've already got that one. Yep. So A4 is a matrix having numbers 1, 2, 3, 4, 5, 6, just like we can see here. And this time we can do various things to get numbers out of this matrix. So when we had a vector, we asked what was the length of the vector. The matrix, though, doesn't have a length. It has 2 dimensions. We ask what's the size of the matrix. So if I say what's the size of A4, the result is a vector having 2 numbers. The first number is telling us how many rows we have in A4, and the second number is telling us how many columns we have. 3. Okay. But maybe we're not interested in how many columns we have, maybe we just want to know how many rows we have. In which case we can do this. We just put a comma and then the number 1 to say, tell me the size of the matrix A4, but only in dimension 1. The answer is 2 rows. Okay, so we can use the size function here to extract information about the dimensions of our matrix. If we want to get numbers out of the matrix, we can index the matrix in various different ways. So here what we're saying is, give me the element of the matrix A4 that's in row 2 and column 3. So row 2 is here, column 3 is here. So we're talking about this element here, which has the value 6. So there we have it. We can use that colon operator I mentioned before. Here it does something different. What it's saying is, in the matrix A4, give me all the elements that are in row 2, but that are in any column. That's what this colon means here, any column. So in row 2, we've got this stuff here. And if we're saying in any column, then that's all of these columns here. So what we will get is 4, 5, 6 coming out. So this is a way of converting from the matrix into a vector, selecting a particular row, or we can select a particular column by putting the colon first rather than second. So here what we're doing is getting the first column. We can build up more complicated expressions. So here what we're saying is, from the matrix A4, give me all the elements that are in any row and that are in columns 1 and columns 3. So column 1 is this, column 3 is that, so what we're going to get is something that looks like this. Paste that here, and there we go. On this one, what we can see is we're saying, from the matrix A4, give me all the elements that are in any row and that are in columns 2 up to 3. Okay, so the columns 2 up to 3 are here, so we're going to get this coming out. There we go. Okay. So you can see that this colon operator is actually very powerful, and it's one of the first things that a programmer of MATLAB needs to get to grips with, because it's so powerful, so useful, that really it's very difficult to do good MATLAB programming without knowing the colon operator inside out. Okay, so I'd encourage you all, if you're serious about MATLAB, to get to grips with this colon operator. Okay, so now that we've got our variables, we can do things with them. So if we have scalars, we can add them together, we can subtract, we can multiply, divide, raise them to the power. For example, 4 plus 3 is adding, 5 minus 3 is subtracting, 6 times 2, multiplying, divide, very easy, 45 divided by 3, and in MATLAB it's easy for us to raise something to the power because we just use this little hack here to raise it to the power. In C, there's no native way of doing that, you have to call a function, but in MATLAB it's built in. And here we've used constants, but we can use variables, so before I've got A is 150,000, I can do A times 2, 300,000. Okay. Something to be aware of is in mathematics, you might type 2x to mean 2 times x. But in MATLAB that doesn't work. If I do 2a, it says, I don't know what you mean. Error. And then it says, did you mean 2 times a? Yes, I did. Okay. So you always have to put the star if you want to multiply. Okay. And that's operations with scalars, but we can also do operations with matrices as well. So if we've got A4 again, there's our matrix, we can do a transpose. So A4, and then we put this apostrophe here, this prime, and that gives us the transpose. We're just flipping it from being horizontal to being vertical. We can multiply 2 matrices together. Now let me set this up. If I do, right, so let's suppose we want to do A4 times by A4. Okay. Now remember, A4 is not a square matrix, it's a rectangular matrix. Can anyone guess what might happen when I do this? Error. Yeah? Error, yeah, because for the mathematicians amongst you, we know that when we multiply 2 matrices together, their dimensions have to be compatible. It is that the number of columns in the first matrix has to be equal to the number of rows in the second matrix. So here we have a problem because A4 has 3 columns, but the second A4 has only 2 rows, so they're not compatible. What we can do though is we can multiply A4 by the transpose of A4, and in which case it makes sense. Okay? So the result is a 2 by 2 matrix because the first A4 has 2 rows, and the second one, transpose, has 2 columns. If we did it a different way round, if we did the transpose of the first one, now we get a 3 by 3 matrix because this has 3 rows, this has 3 columns. Okay. So if this seems confusing to you, it's not. It's your understanding of understanding of mathematics that needs to improve. MATLAB is just doing what mathematicians do regularly. Okay? So don't worry if this is confusing. I'm sure you'll get to the maths in your MSc soon enough. So that's multiplication, and there are similar rules with division of matrices, similar rules with raising things to the power. Other things we may like to do though is an element-wise multiplication. So here, previously we did A4 times A4 and it didn't work. But if I put a dot in here, then now it does work. And because the differences of that dot is transforming it from being a matrix multiplication to being an element-wise multiplication. So if we have another look at what A4 has the values of, 1, 2, 3, 4, 5, 6. When we do A4 dot times A4, what we're doing is we're saying, take the first element of A4 and multiply it by the first element of A4. So the 1 times 1 is 1. And here we have 2 times 2 is 4. And you can see 6 times 6 is 36. So it's just an element-wise multiplication. And sometimes we want to do it this way, sometimes we want to do the proper matrix multiplication. So of course here the dimensions have to be the same. So if we try and do A4 dot times A4 transpose, this time we get the error. Okay. And you can do an element-wise division, element-wise power as well. There are also other ways of doing mathematics in MATLAB. There are built-in functions. So if we want to do the square root of a number, we just type in square root, let's say 16, the answer is 4. So this is what we call a function. Okay. We can add up the different elements of a vector. So So the sum of the numbers 1, 2, 3, 4 is 10. Okay. We can do trigonometry. So the sine of pi divided by 2. So something funny has happened here. What should be the answer? 1. Why didn't I get 1? Anyone? That's right, because previously I renamed pi to be 3. Yeah? So if we had forgotten about that, and then we tried to calculate this, and we didn't know better, then we would have the wrong answer now. So this illustrates the problem with renaming the built-in variables. So if I reset pi equals 3.141592. Anyone know any more digits? 6. 5. 3. Yep. 5. 8. 9. 7. 7. 7. Yeah. 9. 3. 2. 8. 4. 6. 2. 4. Anyone? 2. Just making up random numbers now. Okay, 6. There we go. So if we do it again, there we go, we get 1. Okay? And actually what we can do, if I do format long, then it will show us more digits. I can clear the value of pi and ask it what is the value of pi, and this is what MATLAB says. If we compare it to what we said up here, we might see whether we're right or wrong. There we go. Okay? So trigonometry is something that we can do, that's all built in. Logarithmic expressions, so we can do the exponential, the logarithm, log to the base 10. Statistics, so we can do the mean of several values. There we go. Okay. And if we have a vector, we can do the log of those, and it will give us a vector in the output. Okay. So those are built-in functions. So in general, what we need to do when we use a built-in function is we have the function name here, then we have round brackets to follow, where we provide all of our inputs, and we separate the inputs by commas. Okay. And the function will give us output, and we collect the output together in a set of square brackets, and we separate the outputs by commas. Okay. But if ever you're not sure about how to use a particular function, you can just type help. So let's say we're not sure about how to use sum. Help for sum, and it will tell us lots of stuff, useful stuff about how to use it, and give us lots of examples as well. Okay? So MATLAB's got really great built-in help. Plus, if you click on here, you can get even more useful help in the documentation as well. Yeah, and as I already mentioned, when we do the log of a vector, the result is a vector where we've got the log of each element. So that's what we're saying. Some functions operate element-wise, but the input is a vector instead of a scalar. So let's talk about plotting in MATLAB. So I mentioned that MATLAB is great for mathematics, it's great for programming, it's great for graphics. So let's have a look at how we can do some graphics. So let's do this step by step. So here what we're going to do is create a vector. We're going to call it x, and it's going to have the numbers from 0 up to 1 going up in increments of 0.01. Okay. But we don't get anything on the screen because I use the semicolon to hide the output. Then what we can do is plot a particular function. Okay. So what we're going to do here is give the x values for our plot, and here we're going to give the y values for our plot. So on the x-axis we're going to have a vector which goes from 0 times 2 pi up to 1 times 2 pi, and on the y-axis we're going to plot the sine of this thing. Okay, so when we do this we're going to get a sine function plotted, and there we go. So on the x-axis we're going from 0 up to 2 pi, and then the y is plotting the sine, which is going from +1 down to -1. And if we were to look really carefully in here, what we would see, so between here and here, you can see that it's going to have 100 different points in that vector. Okay, actually 101. 101 different points in that vector. And if we use this tool here, we can look at the values in the vector. But if we look carefully, we'll see that there are 101 points. So this is made up of dots which are drawn together with straight lines. Yeah. And the number of points that we have in here is dependent on this first vector. So to illustrate that, if I change x to being a vector of just 11 points, and then do it again, and then look at my plot, now the straight lines are more obvious. Yeah. So if you want a nice plot, you need to use lots of points. Okay. So let's go back to what we had before. Okay. So there we go. It's back to how it was. Alternatively, we might want to do a plot like this. So semi-log y. So what this is going to be is a logarithmic y-axis, but a linear x-axis. Okay, so semi-log means only one of the two axes is logarithmic, and the y means it's going to be the y-axis. So what we're going to do is plot on the x-axis the value x, and on the y-axis 2 to the power of x. And because x is a vector, we want to do an element-wise raising to the power. Okay, so it's going to be 2 to the power of the first element, then 2 to the power of the second element, and 2 to the power of the third element of x, and so on. So when we do this, plot that, let's have a look, we get a straight line. And the reason why we get a straight line is because our y-axis is logarithmic. You can see the gap between 1 to 1.1 is big, whereas the gap from 1.9 to 2 is small. And that's because this is a logarithmic axis, which makes this exponential function become a straight line. Okay. And if we want to, we can make our plot look pretty by labelling the axis. You can see I've got x appearing here, and we can label the y-axis, and we can give it a title. And so now we've got hello up here, we've got y, and we've got x. We can label the axes in this way. If we want to put more than one plot in the same figure, you'll notice that when I did this, it erased the previous plot, which was this one. If I want to keep the plot, then I can use the hold function to allow me to plot more than one thing at a time. So if I now plot 3 to the power of x as well, then now I've got a plot having both of those two different plots in the same figure. Okay. And what we'll do is we'll just finish on 3D plots. So this is taking us back to where we started. This is the same code that I showed you at the very beginning. But what I want to do is just talk you through what we have here. So what we're doing first of all is we're creating an x vector. The vector is having the values from 0 to 1 in increments of 0.2. We're also creating a y vector. Then here what we're doing is using a function which is built into MATLAB. And this function has two inputs. You can see the round brackets, two inputs separated by a comma, which are the x vector and the y vector. And what this function does is it converts them into matrices. And we have two outputs, square brackets separated by a comma, x matrix and y matrix. Then what we can do once we have these matrices is we can use the expression from before to give us the z matrix, and then the 3D plot is this mesh function. We give it a matrix of x values, a matrix of y values, and a matrix of z values, and it will generate the plot for us. And there we have it. Okay, and like I say, in MATLAB you can do neat things like this. You can move the viewpoints around. Okay, so I think that's a good spot to finish. We've had the 45 minutes. So thank you all, and good luck finishing your pre-sessional, and good luck with your MSc.
Thank you.我就看文档就行了，帮助文档。
矩阵的乘法是同列，然后再相加吗？
它是按照那个，对你自己想怎么算就怎么算。
不是，我是说正常的矩阵乘法。比如说一个。2行3列，如果是 是